If you're working in a small unit and you only care about your own thing and your data isn't a product to anyone else, then fine. You don't need to have it well architected because it works for you. And that's what's important. However, if you're building an organizational data stack and you need to be reporting your data to other departments and bring in data from other departments into yours, then it needs to be well architected. Those coupling points need to be well defined, because otherwise you end up in a big mess. What does that actually mean to be well architected? The main thing is not striving for perfection, but striving for end-to-end use cases that leads to business value. Let's take the question, how much sales are we making? Or what's the profitability of my business? Okay, I need to talk to finance because they've got the actual numbers. I also need to talk to manufacturing because they're the ones that drive the numbers. I also need to talk to sales because they're the ones reporting on the numbers before they become real and we actually bank the money. What we need to do is take account of all of those data sources and all those people that control that data. What is our accounting software? What is our sales software? What are we using to manage manufacturing? We take a look at those data sources and we bring it into one centralized data repository. In the Google Cloud camp, we have BigQuery. You can think of BigQuery as a big spreadsheet in the sky that's infinitely, with an asterisk, scalable. Once your data's in BigQuery, that's the data engineering task done. What you then get into is what we call analytics engineering. Analytics engineering is essentially taking all those raw data sets, and then we have to turn into something useful for our end users. My users, my CEO that's asking for total revenue. I need to build tables using SQL or Python to turn them into something useful, such as a general ledger. Once we have those what we call marked level tables, we then get into data analytics. So we had data engineering, that's getting the data into the warehouse. Analytics engineering, manipulating that data so that's useful in warehouse. And data analytics is actually taking that data in the warehouse that's been pre-prepared and making it useful for our end users and our stakeholders. And that can be many different things, building out dashboards, building out KPIs, building out schedules so you can schedule reports and give it to others, or setting up alerts. So saying, hey, if manufacturing throughput goes down while also sales going up, then we've got a disconnect between the units we have and the units we've sold. That's a stock risk. So when it comes to your data stack, what happens if it's not built to scale? All of this work becomes 10 times harder, 10 times less governable, because people will be doing their own little things without a central identity and access management policy. You end up in a bit of a mess where some units within the business are very data mature, they're doing really good reporting, and some business units that aren't doing any reporting and needs to be. The first step is definitely taking all of that data, bringing it into a centralized place and making sense of it with a small use case.